right, ladies and gents, good morning. Welcome to Activity for Processing 1.5, which will get you ready for your cooldown 1.5. Let's begin. So this entire lesson, along with the one that's coming up, lesson 6, is all about recursive equations, or some people also go by like recursive definitions. There's a reason behind the name. Feel free to do some research, see why this is the case, why we have two different ways to kind of go over it. But the key here is recursive. If you look that up, there are other recursive natures in mathematics, and this is going to get you launched with that idea along with the next lesson. So if you wish to go ahead, dig deeper into the concept, feel free to do a search on that. So let's go ahead and establish some of the vocabulary here. Beginning with what we see here, our sequence is made up of 1, 2, 3, 4, 5 different terms, which we have already covered before those vocab words before. Now we're going to introduce some notation. Okay. So beginning with f of 1, this notation right here is meant to denote the first term. The first term of our sequence can be found all the way to the left. It's the first one because you always read terms from left to right. So this is the first term. So the first term, this is what f of 1 means. The first term, the number one term of the function f is 2. Now, I'm using the letter f, but you could easily use other letters like h of n, or h of 1, because we are h of n, we'll see in a moment, or f of n, we'll see in a moment, but h of 1, you could also write, why am I struggling with this? G of 1, I don't know, any letter really. I was going to say x of 1, but that sounded kind of weird. So let's go ahead and continue. So this denotes the first term, okay? So now we also have the other notation, f of n, and this is meant to represent the term or term value. So f of 1 is 2, f of 2 is 8, f of 3 is 32, f of 4 is 128, and f of 5 is 512, or 512. This sequence is called f of n, and you can change and swap the value of n with any term value, and the output, the value, will be what you see here written in red. So if I were to say f of 4, I'm going to switch out the n with 4. That's referring to the fourth term of the sequence, ladies and gents. So once again, f of n is the term or term value. Now, what's cool about recursives is recur means to like recall, kind of like in this context. So in order to get this term right here, the third term, you need to recur or recall the second term. And if you want the second term, you need to recall or recur to the second term. So what I'm trying to say is this: f of n is equal, or is the result of taking the previous term. That's what this means right here. The previous term. Previous term. And then here in this spot, this is where you put the growth factor. The growth factor, which we discussed, and we also looked at how to find it, can be times 5, it can be plus 2, it can be times 1/5, it can be plus -2, different ways that you can write the growth factor. Another name for growth factor here, some people call it rate of change. This is basically telling you how much is it changing by from one term to the next. So if I can read this out to you, the current term is the result of taking the previous term and doing something with it. So let's look into this problem specifically. So how do we find the growth factor or the rate of change? It's something we've done, but just a quick little review here. Never hurts. So you can grab the second term and the first term, you can subtract them. 8 minus 2 equals 4. And then check if that works, right? So 8 minus 2 equals 4. What am I saying? It's 6. So what we can do is we can add 6. So 2 plus 6 is 8. Now let's go ahead and add that 6 again. So 8 plus 6, that's 14. Oh no, that's not going to work. So what we can do here instead, to find the growth factor, let's use the other operation of division. So 8 divided by 2 is 4. So it looks like we can multiply by 4 and see if that works. So 2 times 4 equals 8. Okay, that works. Let's take 8 times 4, which is 32. Okay, cool. We're in good shape. I'd like to check this one more. 32 times 4, that's 128. Might as well finish it. That's 512. So it looks like multiplying by 4 is what I'm going to write right here, because I have enough evidence here to suggest that the current term is found by multiplying the previous term by 4. So let's go ahead and dig deeper as to what that looks like in mathematics. So that's it. That's the equation along with the initial term being defined, or the first term. So in order to play around with this, we can actually try a value. So how about we actually try f of 4, which we referenced earlier. So f of 4 is the result of taking the previous term, which is f of 3, but I'm going to write it all out right here, okay? And multiplying it by 4. Okay. So f of 4 is the result. And you will notice I substituted the values of n, because right here I'm looking at n equals 4, which is the fourth term. It is the result of taking the third term and multiplying it by 4. So basically, by writing this out, we're saying that the current term, or term value, 128, is the result of taking the previous term, f of 3, right here, this is f of 3, and multiplying that by 4. And that is basically what we're doing there. So we know how to take a sequence, find the growth factor. What we're doing now is we're learning how to use all of the information and the new vocabulary to create these things called recursive equations or recursive definitions, where you need to outline you need to define the initial value right here, and then you write an equation for the current term or term value by showing that we took the previous term and we had a growth factor or rate of change applied to it. Okay, so that's how you create an equation for these things here. So you're going to notice that the only thing that really changes is here, the first part, and the growth factor. Everything else stays put. So I'm actually going to not erase this to make my point clear. So I'm going to hop into example 2, but I'm not going to erase the purple equation for the sake of showing you that this is the skeleton. Now you just add the different pieces and make it fit your equation. So let's go ahead and hop into example 2. What was example 2? What did I have here? 2, 6, 10. Sorry, I'm just looking at my notes here. So if you want right now, this is a fabulous moment to pause the video and see if you can define the first term and place the growth sequence here. And there are two options as to your growth sequence. You can either add by a growth factor, or you can add by a growth factor or rate of change, right? I think I said growth sequence. My apologies, growth factor. Okay, so I'm going to go ahead and continue here. If you want to pause or unpause, up to you. So the first value or the first term is 2. Now, the current term is a result of taking the previous term and doing something to it. Okay, I'm gonna go ahead and say we're doing this. We're adding by 4. So if we're adding by 4 each time, plus 4, plus 4, plus 4, plus 4, this works. And that's it. That's your recursive equation. So a recursive equation, once again, I'm going to summarize, is made up of 2 parts. Defining the original or the initial value, the first term, and then writing the equation out, where the current is a result of the previous with a growth factor or rate of change applied to it. Okay. All right, let's go hop into our last example. So let's say instead we have, oh wow, I got really interesting with this one. 50,000. What was that? 5,000? Why so many commas? Here, I'm going to underline it. So 50,000, 5,000. What's the next one? 500. 50 and 5. Wow. That seems like fun. Okay, so the 5 terms of our sequence are laid out, and I underline them too because I know the commas can be a bit overwhelming. So we have 50,000, 5,000, 500, 50, and 5. So you might be thinking to yourself, oh, you're dividing by 10. That's not incorrect, but it's also, I'd like to remind you that when we're building these sequences, we want to use either addition or multiplication. So we can actually rewrite division of 10 as multiplication by 1 over 10. Okay, so use this. This is not incorrect, but this is not going to get you the equation built, and that's what we're trying to do, is build an equation using a growth factor that is either addition or multiplication. So let's go ahead and actually write it out. So f of 1 here, remember, pause the video here if you wish to experiment here. It's 50,000. And now let's go ahead and write the equation. F of n is the result of every previous term being multiplied by 1 over 10. And that is it. Now, I'd like to talk about one last part of our equation that I haven't written out, but I saved it for last because it takes a little bit of explanation, and if I explained it in between, it would probably get muddled. What's important is that you also need to define this last part. N is greater than or equal to 2. Why do we need to do this? So over here, I'm going to go ahead and put this here too. N is greater than or equal to 2. Let me scooch this over just a bit. So at the end of every equation, and if I could go back to example 1, I need to write this down as well. For n is greater than or equal to 2. For n is greater than or equal to 2. Now, real quick, before I explain why we need to write that at the end of our equation and define that, I'd like to just show you folks, if you don't have the greater than or equal to symbol on a keyboard, this will replace it. You can write greater than or equal to. You can write this symbol, and it'll mean the same thing as that one. Okay. So the reason we write n is greater than or equal to 2 is because we already have n is equal to 1 here. This is taken care of. So we automatically need to start with the second term here. So this right here is already taken care of. So n equals 1, which is the first term, is already defined here. Now the rest of the equation will take care of n equals 2 and all values greater than that. So this is n equals 3, n equals 4, and n equals 5. And if we kept going, it would define all of those values. So it's like you have to separate the first part of the equation, which I circled down here, and I will circle or rectangle the second part of the equation right here. These two together create your recursive definition or recursive equation. However, they are listed separately because in a recursive definition, the special nature of it is you need to define the first or initial value separately from the rest of the equation. All right, so good luck with this. Have fun.